Here we're given the equation absolute value of x plus 3 outside of the absolute value symbol equals y. And now we're asked to check for the symmetries of this equation. The first type of symmetry we're searching for is the possibility of an x symmetry. So for the solution, we start off by replacing y with parenthesis negative y. We get the absolute value of x plus 3 is equal to negative y. Did that change the equation? Yes, it did change the equation. That is not the same as the original equation. It's not absolute value of x plus 3 equals y anymore. It equals negative y. It changed the equation, and that makes us conclude that there is no x symmetry, no symmetry about the x-axis. Now let's check for y symmetry. Replace the x with parenthesis negative x. Absolute value of negative x plus 3 equals y. Let's simplify that. The absolute value of negative x is the same as the absolute value of x. You know that. Why is that true? That's true because absolute values makes everything positive. Okay? And that means that it looks just like our original equation, absolute value of x plus 3 equals y. This equation is unchanged when we make that substitution. And from that we conclude that there is y symmetry. In other words, there is symmetry with respect to the y-axis. And finally, let's check for origin symmetry. Replace the x with a negative x and replace the y with a negative y. That makes our equation absolute value of negative x plus 3 is equal to negative y. Now simplify that. Let's see, well, we can replace the absolute value of negative x with the absolute value of x because they have the same value. Bring down the plus 3, bring down the equal sign, bring down the negative y. But that doesn't look like the original equation. So it changed the original equation. Therefore, we have no symmetry about the origin, no origin symmetry. So only the situations where the substitution caused no change to the equation when we simplified it, those are the only conditions under which we have symmetry.